So, all right, advection and diffusion operate together. Okay, both are three-dimensional processes and so on, but I only give you two-dimensional. Okay, so for example, if you have a point source of some substance, a dissolved substance, you continuously pump a pollutant into the ambient fluid, you might get a distribution of your concentrations as shown in this sketch, whereby the numbers are the fractions whereby 1 corresponds to 100% and lower numbers to lower percentage concentration. Okay, so at the source you have 100% concentration, and then you can look at the distribution here. What you see is you can see a center line. Okay, you can see a line along which the concentration is at maximum compared to the direction which is perpendicular to. Okay, so you can connect, or you can create a center line, this red line, and this red line actually tells you the direction of the advective component. This is what the advection does. The advection moves the center line along its specific shape. Okay, so this is the positioning. The diffusion that also operates at the same time leads to a decrease in the concentration, and it's most obvious to see this perpendicular to the pathway of the flow. So if you move away from the center line, and this is the center line, you move away, the concentration decreases. This is due to diffusion. But diffusion also reduces the value, the concentration along the center line. You can see as you move along the red line, concentration is decreased to 80%, 70%, 60%, 50%, 40%. So from these type of shapes, you can determine the pathway of flows in the ocean. Okay, and I've given you examples in the lectures. One example is shown here. So this one is the spreading of Antarctic bottom water. And you can see the same structures here. You can see that, infer that there's a source. Okay, this is the Ross Sea, and then you can see these tongue-like structures. You can see tongue-like structures emanating from the Ross Sea and one from the Weddell Sea. And then you can even see substructures that move, different tongue-like structures move into. And this is all based on this concept of advection and diffusion. These are the fundamental processes at the same time in the ocean. You have to be a little bit careful because, in fact, the oceans are three-dimensional features. Okay, and you have to be a little bit careful that at times you can get artificial distributions that only look like this only because of the transect that you're choosing. But anyway, so you can think about that in your free time. Okay, but this is the principle by which you can derive flow patterns in the ocean from sources. You have essentially point sources of very, very cold water here